today, but I've already practiced everything. So, so now what I'm trying to do is figure out how to make both these devices work without this echo.
Disconnect the audio for the audio from one of them.
Yeah, I've done that. I have this muted and no video, but I'm still seeing the video. That's because all right, well, I left that one. Dad, you got a question? Your hand's up. What do you want to talk about?
Sorry, it's the mistake.
Oh, okay. All right. So once again, today I got my list. For those of you that are not permitted to step foot on campus. And there's 3 of you guys that were logged in at 9:30 that are on that list. So I'm sure you guys are getting those emails as well. So whatever it is you need to do to handle that, try to handle that before we have a test. Really don't see us having a test next week. You know, that would be week 3, and I'm kind of thinking the first day back is going to be a wasted day anyway. I mean, some of you guys don't even know where Orange Coast College is. You know, some of you have, you know, just graduated from some high school and started doing online Orange Coast College, and you know, you might never make it over to this side of Costa Mesa or something like that. So, and then even if you have driven by OCC and maybe you were on campus a long time ago for one reason or another, things are quite different, man, with all of our new buildings and shit. And parking lots are different now in Adams. If you guys haven't been over there, there's all those solar panel things. And the new Litton Lang building is right next to the building that I'm cursed to spend the rest of my career in. That's some kind of a prison sentence. And then, of course, there's that brand new student center that looks pretty cool. Maybe some of you guys went over there and went in there. How about any of you guys? Were any of you guys here when all of this stuff started? Like, were you at OCC? Like in February of 2020? And
I was at school last semester for chemistry lab. I saw them building the solar panel in the Adam lot. They cut off the whole thing, so we have to park outside.
Yeah, one of the things Rich Pagel said at our last Flex Day. You know, by the way, we don't have school a couple Thursdays from now. I think it's the 24th. I mean, I have to do a bunch of shit that you guys don't. It's what's called Flex Day, where they force us to attend meetings about stupid things that nobody cares about. But anyway, yeah, so you guys are going to have to figure out where to park, you know, where your classes are. Maybe you got more than one class on Tuesday, you know, one of your classes is in MBCC and the other one is in the Lewis Center, and maybe you have a third class in fine arts and you don't know where any of these places are. So I won't be taking any attendance on the first day back, realizing that some of you guys are going to be lost, you know. But I will be broadcasting, and I checked out my cords and all that stuff, and everything works. Only thing that I can't figure out is why I can't be on my mini iPad at the same time and have an echo. Well,
You have to turn off your microphone on that one.
on the mini,
Yeah,
let me see, because I have to. This is how I'm going to be doing things, so I need to learn how to do this. So I might as well learn this now here versus I was going to try to do this at school today. So
Professor, the way I do it.
what?
The way I do it when I join from two devices, for example, my computer and my iPad, is you see there's three buttons on the top right of your iPad mini screen that says more.
Uh-huh.
Click on that and then scroll all the way down to disconnect audio.
Okay, I've disconnected the audio.
Then it would just show the video. It won't be able to pick up any like voice or transmit anything that anyone says in the Zoom call.
All right, I got it. So this is how the plan's going to go. It's like I'll be broadcasting on this thing, but if I need to, like, it's inevitable I'm going to end up writing on the board, and I'll be able to use this second device here, like, to go, because this thing I can just walk around with in my hand and go, and instead of having it, you know, looking at me. I'll just point it to the, you know, to the board and say, okay, this is what I just did. I don't know, it's going to be a learning experience, learning curve, that's for sure. All right. So any of you guys have any integrals that you want to see done?
I'd like to see more of that substitution rule from the last class.
A few more like trig substitutions?
Yeah,
Okay, well, we're going to be doing some of that stuff today. And I also have a video that at some point, maybe today, I'll share the screen and play this video, but it's related to a problem that I'm going to be working on here in a second. Okay, well, let's get started with all this stuff. So, flip this thing around. I think at the end of class, I'm going to switch to working on the mini and seeing what it's like to write on that thing. All right, so let's do a couple more of these, the substitution problems. Are any of you planning on just not showing up on Tuesday? Like you have no, well, some of you can't, according to this list. You realize if your name's on this list, I'm not going to be asking you, whatever, but I'm sure there are going to be people walking around. There's probably something like they have to make an effort to at least seem like they're complying. But you know what? Isn't all the mask stuff going away next week in the state?
Yeah.
For
Yeah,
those vaccinated, yeah. But it might be on local or county levels that they might keep it.
I can tell you this: in Newport Beach, no one wears a mask anywhere. People walk right by the mask signs, and it's like if I go to, there's a Circle K that's technically in Newport Beach that I go to half the time, and then there's this one on Wilson that's closer to my house. And the one on Wilson, everybody's has a mask thing in the window, and most people are going and wearing a mask. And then there's the one up off 17th Street by where Ross used to be, and no one's wearing a mask in that one.
You got to see the difference between Orange County and LA County. Like here, you barely carry masks, and then you go to LA County, you have to wear the mask.
This Orange County is worse than LA if you compare it to like Marietta and Temecula area. No one, and I mean no one wears masks up there.
Oh, San Diego?
Yeah, I have Temecula,
yes.
Marietta area.
Yeah, Sandy. That's where my parents are. That's where I'm kind of grew up. A town called Vista. Yeah, no one's wearing masks down there. You know why? It's because it's more of a red area. Like LA County is mostly a blue place. Like a red state, blue state. LA County is like mostly blue. Whereas San Diego and Orange County, at least the Newport Beach part of Orange County, is mostly red. So my best friend growing up, he lives in Florida, and we missed a football season, but his kids didn't that one year in 2020. And I'm all pissing him on, and he goes, "Man, that's because you live in a blue state, man. You got to move to a red state where pay attention to any of this stuff." So anyway, looks like we're all getting close to getting back to normal. All right, here we go. Start the broadcast. And yeah. Remember this fun stuff? This is what we were doing yesterday in Math 180. Okay, so flip it over. And now the one thing that I haven't figured out is on OneNote on my iPad that I'm on right now. or whatever it's called, the big one. All of the stuff on OneNote isn't, I'm not able to access it on the new iPad.
It's probably because you saved it locally. I'm not really familiar with OneNote, but there's probably a setting somewhere that like says save it in cloud or something.
Yeah, see, like all these things that I've done, it'd be nice if they all showed up. I mean,
Yeah,
there's a way to do it. I just need to
Yeah.
figure out how to do it, All right, so what did I do with the cord? No, last night I packed a bunch of stuff up thinking I was go over to school, then I realized, that's kind of stupid. I already know how everything's working. All right, so let's look at a problem here. So this is, let's say, y equaling the positive square root of 1 minus x squared. Okay, and this is the point 1, 0. Or better yet, let's change this to a t. So this is now the t-axis and the y-axis. And let's figure out the area bounded by this curve. So the area of this thing would be the integral from 0 to 1 of the square root of 1 minus t squared. So we need to do a trig substitution on this guy, right? So how about if we were to let t be the sine of theta, then dt would be cosine theta, d theta. Right? Okay, now, as far as the bounds go, since we're living in the first quadrant and all that stuff, when t is equal to 0, that corresponds with theta being 0. And if t equals 1, that means that the theta would be pi over 2. Okay. So plugging everything in, the area is going to end up being the integral. Now it's a theta integral. And it's going to be the square root of 1 minus sine squared theta, then times the cosine of theta, d theta. Okay, now, anytime you have a definite integral, you definitely need to start asking some questions, you know, like, all right, if you're taking the square root of something squared, which we are, is everything going to be positive, or like yesterday, do I have to like separate it up, or on Tuesday? So anyway, we get this integral from 0 to pi over 2 of cosine squared of theta d theta one half minus 1/2 the cosine of 2 theta d theta. And so this is equal to theta over 2 minus 1/4 the sine of 2 theta evaluated 0 pi over 2. All right, and so all of this stuff here, because it's 2 theta, all that stuff goes to 0. And so our answer is going to be 1/2 of pi over 2, which is pi over 4. Okay, now of course we knew this answer, right? Because this is a fourth of the circle. Okay, so what if I was to put an X right there and then try to figure out a couple different areas, like maybe figure out what this area is, and maybe figure out what this area is. All right. Well, let's start thinking about that a little bit. Let me move this table thing here. Hold on 1 second. All right, well, what would this be? Let's call A of, let's call A of X equal to the integral from 0 up to X of this square root of 1 minus t squared dt. All right, so it kind of looks like trying to figure out that area, right? All right, well, it's still all going to be the same stuff, right? So it's going to end up equaling after we do all of the substitution stuff, it's going to be theta over 2 minus 1 over 4, the sine of 2 theta, where the substitution was t was equal to the sine of theta. Okay, so the sine of theta is that, right? I have a ingrown hair in my nose. So painful. Okay. And there are some bounds here, you know, that we're not changing just yet. Okay, so this is 1/2 of theta minus the sine of 2 theta is 2 sine theta cosine theta. And this is all going to be evaluated, you know, some places. Okay, so now let's undo the substitution. So this is 1/2 the sine inverse of t minus 1/2 t square root 1 minus t squared, evaluated at 0 and at x. All right. So the sine inverse of 0 is 0. And then plugging in the 0 right there, we get a 0. So what we end up with is 1/2 sine inverse of x minus 1/2 x times the square root of 1 minus x squared. Okay, now let me see what else this exercise is trying to point out with all of this stuff. Da, da, da. So I don't know exactly. He kind of stops right there and just, you know. Now, what about this area right here? Well, there's a couple of things we could do, right? One thing, how about if we call this A2 of x we might have that this area would be from x to 1 of the square root of 1 minus t t squared dt. Now we don't have to reinvent the wheel, right? We can do this. 1/2 sine inverse of t. The reason I wanted to do this problem was because it's kind of related to this video that I was thinking about showing you guys. It's on how Isaac Newton revolutionized the way everybody estimates pi. 1 and at x. Okay, so when you plug in a 1, we get that, right? Minus 0 minus then 1/2 sine inverse of x minus 1/2 x radical 1 minus x squared. And so this a2 of x is equal to pi over 4 minus this exact thing that's right there. And since we know that the entire area is pi over 4, we have that. All right, any questions on that problem? Nope. All right, let's go find another one to do. Um, this is an interesting one. It's been a minute since we did anything with this guy. All right, so I want you guys to do trig substitution, work on this for about a minute or so. What's your substitution? Well, you work on that for a minute. I might go check on the dogs. All right, what'd you guys do? What'd you let X equal?
Tangent squared theta.
X equaling A tan theta, right? So that means that X squared plus A squared is going to be A squared which is A squared tan squared plus 1. Oops. Okay. Of course, dx is going to be A secant squared theta d theta. And what we end up with is the integral of dx, which is A secant squared theta d theta divided by square root of A squared all right. There's no bounds here, so we're just symbolically manipulating things here. So what we end up with, and we're assuming that the A is positive and we don't have to play. There's a lot of stuff that we do that we just kind of excuse when it seems like it's in our benefit. You know, I'd really be interested in seeing. I should text her. I wonder if Mariana has some of her textbooks from when she was growing up in Romania. Because, you know, we all piss and moan about whatever, and then she's always a cold bucket of water. Like, guys, I grew up in communism. Please, you know, we're like, okay, good point. That'd be a trip. Grow up in a communist country and then end up living in Southern California, working at Orange Coast College, as opposed to teaching all the coal miners how to long divide back in your village in Romania. All right, so we should have this guy committed to memory. Hopefully you guys do by now. Natural log. Now, during this normal times, there's always a question about, do I need to show you my work on this one? And there are a couple where I say that you have a pass. You know, you don't have to show me your work on this, and nor do you have to show me your work on this one. You guys need to memorize this integral because it shows up all the time. Okay. And what do you say we go back to the way Bobby used to do things? So back in 2019, I had a 185 class. And just as I had done every previous semester for the last 15 years, I promised the entire group that this would be number 4 on exam 1. And every time it rears its ugly head, I ask the question, hey, what's so important about that integral? And the answer? Well, it's going to be number 4 on exam 1. So I'm probably going to do that again with you guys. By the time we're taking this exam, we'll kind of be back together, and I guess. I think the way that I'll do exams is I'll put a sign-in sheet. You guys are going to have to show up. Or maybe I'll write the exam up, make a bunch of copies of it, and then you guys walk in. And that way you can have a hard copy of the thing, but I'll publish it on Canvas anyway. That way, if you show up and you don't, and all you have is your phone, then you can work out all the problems, put the answers down, take a picture, and upload it to Canvas. And I think the show me your work days are kind of over. You know. I'm even starting to like even change my thinking about cheating. You know, because this entire last 2 years, this has been nothing but cheating, right? You guys don't do any homework problems, just wait for the test. And I don't know, maybe one of you knows all this stuff and just writes all the answers down in the Discord, and or maybe you hire somebody to, you know, some tutor to do them. But anyways, for you guys that were like actively participating in that, it's not such a bad thing, you know. I can tell you for a fact that when you guys have a real job, let's say you guys graduate and get a degree in some kind of engineering or something like that, you know, like my buddy Pat. So I have this friend Pat, he used to work, Patrick, he used to work at Cycle Works, this old bike shop that I used to go to all the time. And it's just, you know, a mechanic, but he was going to school at OCC, took me for all the calculus courses, and then transferred to Cal Poly Pomona, got his bachelor's in mechanical. Didn't have to take any of the EIT tests because he found a job in Lake Forest. All he needed was an engineering degree. But, you know, when I talked to him, he's like, we have these problems and we all work on them together, you know, no one's sitting there by themselves. You know, like when I had the real job, Nora would call me from Scripps and you know, say so-and-so is retiring at the end of the month. Can you calculate his benefits? Sure. You know, take me 15 minutes, but even less than that, depending on how slow the database was. But I couldn't just call her back, you know, it had to be peer reviewed. I had to go get it checked by this person and this person. We never did it on a phone call. It was always a fax. Apparently there was more money in sending a fax to the company. Because every time she did this, you know, we collected a fee. Our bosses did. And sometimes she, you know, call me at 10 in the morning. I wouldn't get back to her until 3:30 in the afternoon because of all of that shit. All right, so let's undo our substitution. So our integral ends up being the natural log . Uh-oh. My wife has a. I can tell my wife's frustrated with the student she's counseling right now. Are you listening to me? Okay. So the secant of this theta is the square root of x squared plus a squared over a, right? And the tangent of that theta is x over a plus a constant c. All right. So if a is equal to 1 specifically, then this integral which I talked about last semester, not this integral, but I talked about this and then plus 1. And then, of course, we have plus a constant c. And you guys aren't paying attention. It's not plus 1, plus x. Okay, now, if you check this in the book, what we would get in the table, and another reason I didn't go over to school today was because I thought, why would I waste my last day of vacation not being able to sit on my couch and talk about all this shit? I mean, right now I'm like in my gym clothes, because as soon as I hang up with you guys, I usually work out, although I do have to do something at 12. So we have to end at 11:45. I have to get somebody over to the dentist. Anyways, so in the table of integrals in the book, let me just dig around here. So where's all the table of integrals in this particular calculus book? Probably in the back of the book. All calculus books have these tables of integrals. And of course, I select the one book that doesn't have all these fucking integrals. Doesn't. That's supposed to be cut out. Okay, what the fuck's going on here? Time out. So, index. Nope. Wow. Did they really stop putting tables of integrals in these textbooks? I have to drag out my older book. All the tables of integrals. There it is. Okay, so it's in a different spot in my book apparently because I have an instructor's copy. So when I checked this in the textbook, in the table of intervals, and this is how physics majors they spend so much time in these tables of intervals that eventually they at least committed to memory. So where the fuck is it? There it is. Um, there we go. Now in this table of integrals, it's looking pretty good. However, in this one textbook that I have, that's the one I'm looking for right now. You look up the answer. I think this is in, what is this book? Thomas, something like that. Anyways, checking this in the book with just a 1, what we get is the hyperbolic sine inverse of x plus some constant c. Okay, now, because I don't know your background, I don't know where you came from. If you came from me, I kind of went through these things. The reason I'm bringing this up is there's a contingent of people that are teaching Math 185 that don't even cover the hyperbolic functions. And so I thought this would be a good time to talk about this stuff. Okay, so apparently these two things are the same. All right. So back in section 311, we had three identities. With these hyperbolics. One of them was the hyperbolic sine inverse of x is the natural log of x plus the square root of x squared plus 1. Note, no absolute value sign, okay? We have an absolute value sign over here, but no matter what value we pick for x, when you square it, it becomes positive. You add 1 to it, you're going to get more than the absolute value of x. So when you take the square root of that, you're going to get a positive number whose magnitude is bigger than the magnitude of x. So now I'll work all this out here in a second, okay, why we don't need that. The other one this is the one that I usually work through. The hyperbolic cosine inverse of x is equal to the natural log of x plus the square root of x squared minus 1. Now here the x is bigger than or equal to 1. And the hyperbolic tan inverse of x, depending on what textbook you have, this 1/2 sometimes is written as a radical. Like so. All right. So every now and then you'll be doing a problem and you'll get your answer as a natural log of something, and you look up your answer in the book and it's something quite different, so these are some things that think about. All right, so let's try to establish this first formula. Let's see. I always establish the second one. And so let's say that y is equal to the hyperbolic sine inverse of x. So that means x is equal to the hyperbolic sine of y. And this is just all symbolic manipulation, Oops, I didn't mean to do that. Hang on. So I'm starting to bleed power. I didn't go over to campus. Oh, shit. Didn't go over to campus yesterday. But on Tuesday I did. And all of everything worked. The projector thing, it just didn't work in the room that I was in. But Tara texted me yesterday saying that 162 is up and running. So what you can expect next Tuesday is I'll show up over there sometime around 8:30. Open up the classroom. You guys will see all the masks and disinfectants and all that stuff. And then you can go ahead and do whatever you want to do. I'll be over in my office probably. And then come in at the beginning of class. I used to pass a roll sheet around because everybody used to get on my ass for not taking roll. What if they get accused of robbing a bank? You'll have a... Okay, so now I'm certainly not passing around a piece of paper that all you guys are going to share your germs with each other. I think I'm just going to have a check-in sheet on test day where you walk in and just come up to the front and check your name and go sit down and do the test. Okay, so now we got to remember the definitions of these things. Now, this is a good exercise for us to do because we're getting back to in-person stuff. And you're going to need to know how to do this on your own without relying on the person that's in charge of the Discord and all that stuff. Okay, so if I was to clear the fraction here, I'm going to get that e to the y minus e to the negative y. That's equal to 2x. Okay, so now I'm going to do a sneaky dirty trick here. I'm going to factor e to the negative y out of this side of the equation. And so what I'm left with is e to the 2y minus 1. And that's equal to 2x. And so this says that e to the 2y minus 1 equals 2x e to the y, which I can write as e to the 2y minus 2x e to the y minus 1 equaling 0. Now this is e to the y squared minus 2x e to the y minus 1 equals 0. This is a quadratic in e to the y. And what do we know about quadratics? What's the answer to that question?
Everything.
Everything. There isn't anything that we don't know about quadratics. We know how to find all the zeros. We know if they're real or complex. We can graph them. We can find the focus. We can use them to build things. And there's just, we know everything about parabolas. So if this is going to equal 0, that would mean that e to the y would have to be negative b plus or minus the square root of b squared minus 4ac, right? All over 2a. And so e to the y is going to equal 2x plus or minus the square root of 4x squared plus 4 over 2 2 square root of x squared plus 1 over 2. So e to the y could equal either x plus or x minus the square root of x squared plus 1. Okay, now we need to rule one of these things out. Okay, So let's start down this path. What if e to the y was equal to x minus the square root of x squared plus 1? I think that this would be a problem because if we were to let f of x equal this x minus the square root of x squared plus 1, I'm pretty sure f of x is negative for all values of x. Now, how could we demonstrate that? Well, first of all, let's just try a few numbers. You know, like what's f of 0? -1, right? What's f of 1? 1 minus the square root of 2, that's negative. So how can we show that something is negative?
Call it less than 0.
Right, so if we want to show that something is negative, and just to be sure of this, you know, what's f of -1? Well, that's -1 minus the square root of 2, right? So sometimes what we do is we haul out a calculus argument. You know, if we want to show that something is negative, well, we need to kind of, before we get all carried away with this, we need to go back up here to the original problem. There is no restriction on the x. Okay, now if you go back and read the section, the reason is because when you graph the hyperbolic sine inverse of x, it looks like this. It kind of looks like the x cubed function. And so this is 1-to-1 everywhere on the real line. And so it's invertible. And so it's invertible everywhere. And so that's why we have this part of it. When you graph the hyperbolic cosine inverse, however, you get something that looks like this. And so, and that's the solution of a famous problem. Like if you have two, like, let's say you have two walls that are rigid, they're not moving, you know, secure. And if you were to hang a cable in between, this cable will take on a very specific shape. And what it is, it's a hyperbolic cosine inverse. I mean, it's a hyperbolic cosine graph. It's actually what it is. All right. Okay, so let's see. We claim that x minus the square root of x squared plus 1 is negative. Okay, so let's see if we can establish this. Suppose not. What if x minus the square root of x squared plus 1 was positive? Well, that would mean that x would be bigger than or equal to the square root of x squared plus 1. Okay, now, here is where we have to do some human intervention. Okay, the square root of any quantity that we put in here is positive, right? That's what that symbol says. So what we have is that x, which is, we're assuming, to be bigger than x squared plus 1, all of this stuff is positive. Okay, now, here's the squaring function. When you get past 1, if I was to square this, this would be bigger than or equal to this, because everything is positive. And not only that, we could even go further with this. This is bigger than or equal to 1, right? And as long as we're bigger than 1, if you square an x, it's going to be bigger. X squared will be bigger than x. So what this leads to would be that x squared is bigger than or equal to x squared plus 1, or 0 is bigger than or equal to 1. That's a contradiction. So what we can conclude here that x minus the square root of x squared plus 1 is negative. Thus, e to the y equaling x minus the square root of x squared plus 1 would be negative. And this is not possible because e to the y is always positive. So that means that e to the y must be the other one. Now, if you're bored, you can go work through the cosine one. That one is a little more challenging. Y, which was the sine inverse of x, hyperbolic, is equal to the natural log of x plus square root of x squared plus 1. Any questions on that one? Here's what Tim said. Can't wait for the shit storm on Monday. Are all you guys getting these reports of your non-cleared students? He says he's got 25% of his students.
Professor, can you roll up a little bit?
Up there?
Yes.
All right, so every now and then, something like this happens. Scroll down here. Mhm. All right, well, it's a good time to take a break now, so let's go ahead and do that. So this is what we're going to do next Tuesday. We'll take a break. So I'll go check my mailbox. Did you say this problem will be number 4 on the test? Yeah, it's probably going to be number 4 on the test. Secant inverse. Or the secant cube integral. And you don't even have to show me your work. All right, so let's take about a 10-minute break or so. We'll be back in about 10 minutes or whatever.